Okay, tougher antiderivatives. Okay, so when I look at this example number one, I have to think about what do you think I started with? And my guess on my start is that I had 4x cubed plus 7 to the 6th. Okay, I probably had something in front of it though. So let's just derive this. So if I derive this with the power chain rule, I get 6 of those to the 5th times the derivative of u, so 12x squared. So 6 times 12, so that's 72x squared. Okay, so this compared to this, okay, I ended up with a 72 that I didn't have. So to counteract it, I'm going to put a coefficient in the front. So the antiderivative is 1 over 72, 4x cubed plus 7 to the 6th, and then there could have been a constant. Okay, next, also a power chain. So let's test our start. So 5x to the 4th plus 8 to the 10th. Okay, so if I start with that, I would get 10 of those to the 9th times the derivative, 20x cubed. So this would be 200x cubed. Okay, so looking at this compared to what I have, what would I need in the front to change this 200 into a 3? So 200 divided by 3. Oops, sorry, other way around. Right. What? Right, I would need a 3 divided by 200 because I want to get rid of the 200. Okay, so 3 over 200. Okay. Next. So remember that this is the same thing, right? So my start, remember I'm going to take a guess that I'm going to start with a 5th power. Okay, so power chain says to go 5 of those to the 4th times the derivative of that. So what's the derivative of cos functions? Sine times the derivative of that. So I have 2 chains after. Okay, so I'm going to put the 5 and the 7 as 35, sine 7x, cos 7x to the 4th. So I have this, I need to counteract the 35. So I need to put a 1 over 35 in the front. And then, can't forget the C. Okay, next one. So I am going to test my start with e to the 3x squared. So if I have that, the derivative of that is repeat times the derivative. Okay, so what do I need here that got me a 7 instead of a 6? So what would I times? 7 over 6. So 7 over 6 is in the front. Okay, what rule do you think this is? And I'm thinking if I have an ln of u, it's going to be 1 over u times u prime. Okay, So let's pretend or guess that we started with the ln of 6x squared plus 32x. So if we did, it'd be 1 over times the derivative of that, so that'd be 12x plus 32. So looking at my result compared to this, what do I need to times this by in order to have that? So I could see that I'm 4 times bigger than that, so I need a quarter in the front. So my answer is a quarter ln 6x squared plus 32x. Right, next one. So what do you think you started with? 4x cubed plus 7 to the 11th. So if we power chain rule it, 11 of those to the 10th times 12x squared, 12 times 11 is 132. So looking here to there, what would I need in the front to end up with a 3? 3 over 132. Okay, so that's what we needed to put in the front of that. Okay, I think I'm going to skip this one. It's basically the same idea. We've done a few. We'll do one more of these. So what do you think you started with? E to the 8x squared. So if you do the antiderivative, or sorry, not the antiderivative, if you derive this, you get e to the 8x squared times 16x. This doesn't quite look like that. I need to multiply something to get a 2 instead of a 16. So get rid of the 16, so therefore 2 over 16, or 1/8. Okay, next one. So I would have started with a sine 3x to the 5th. Okay, power chain rule. 5 sine 3x to the 4th times the derivative of that. So the derivative of that is going to be cos 3x times 3. So 15 okay, so I ended up with this, but I wanted to end up with a 3, so I need something in the front, and that would be 3/15 then, or 1/5. Please remember that that could also be written as that. Not this though. This is something different. This is a 5 that would be applied to just the x. So that's not what you want. You can either say the whole thing to the 5th or like that. Okay, so what do you recognize here? Probably an ln. So let's say that you started with this. It'd be 1 over that times the derivative of that. Okay, look at my results. Mine is 6 times bigger than what this is on the top, so therefore I would want a 1/6 in the front. Okay. Next one, I'm going to rewrite this with an exponent of -1/2 on it. right? It's the same thing, square root of the half, and when it's on the bottom, it's negative. Okay, so therefore, what would I have started with? So 1 exponent bigger is a half. So let's derive. So I get a half of that to the negative a half times the derivative of the inside. So a half times 6 is 3. Which is like that. So here's what I got, and here's what I'm supposed to get. So I got 3 times bigger. So what would I need in the front? I would need to put a 1/3. Okay, that could also be written as right, because a half is the same thing as a square root.